Hi, my name is Rickenbach for CSC842, and my first project is a directory integrity verification tool. And why I created this is at work I have to do a lot of verification of files by checking to make sure the hashes of what are installed on the system are actually what are approved. So typically we're doing this mainly on Windows-based systems, but I have had to do this on Linux systems and other Unix systems. So I was hoping, well, let me show you what I have been using. Up till now I've been using a Windows-based tool from Microsoft called the File Checksum Integrity Verifier, or FCIV. And it's a very good tool from Microsoft. It's a command line tool, lets you do MD5 or SHA-1 hashes of files, and these can be stored into a database. And then you can use this database to check to make sure that the files in those databases haven't changed, and the databases haven't changed. So the problem I have is you can check to make sure that the files in a directory haven't changed. You can see if the hash changed. You can see if a file is no longer on the disk because it's not available to be hashed. But what if somebody adds a file to a directory that you're interested in? Like you add a DLL to Windows System 32. You're not going to be able to pick up on that. And that's one of the things I've been wanting to address for a while, and this project finally gives me an opportunity to do it and learn some Python. And doing it in Python, it's portable. Can use it on a Linux-based system or Apple as well, OS X. And let's take a quick look, see how it works. Right now we're in Module 1, that's where I've been building everything. You can see a whole bunch of files, and we'll just do see the help screen. So whoever recommended argparse, a big thank you, because this is instrumental in getting this done. So you can see DIVT, the main argument it has is the database. If you have a database, all you need is to run DIVT and that database, and it's going to go out, look in the directories that are in there, and then do the comparisons I spoke about. I'm just going to demonstrate that to you in a moment. But if you don't have a database, you can use the optional arguments to create a database. You can do that by a -d and giving the root level directory. You can do a -r to do recursion, and a -t to do a type. And if you ever use FCIV, the type is pretty much spot on to how that's done. So let me give an example of how we do this. So we'll do divt.py. The current directory is dot. We'll add, we have a lot of Python files, so we'll do a type of star.py. I also have fciv.exe in there, so I'll do a type. So we like looking at exes. And we'll go recursive even though there's no subdirectories yet, so I'll show you how this works. And database, we'll call it 842.db. Now 842.db already exists, and it's not going to let me overwrite it. So, which is how I wanted to do it. You could have a append to it, which is what FCIV does, but that's messed me up on more than one occasion. So it's just enough to do. And we'll run it again. So it says 11 files were added. And if we look at the py and .exe files, there are indeed 11 files there. And now, again, if we just have that database made, we can run it, and it will tell us that a hash 11 files and there were no problems found. Now we can start going in. Let's just say this is saving to the current directory. We'll save it, and we'll run again, and you'll see that the divt.py changed. What else do we have? I can just delete. Let's do this. And we'll just move the FCIV down to the junk directory. Oop, not in Unix anymore. Okay, now it's going to tell you the hash mismatch we saw before. It's going to tell you it can't find the file that we had originally in the top level directory, and that tells you there's a new file found in fciv.exe or the fciv.exe. We can also do, we made the junk directory. So now we have junk and fciv.exe. We run it again, and it doesn't show up because we don't care about .text files. We just said we want to look at .py and .exe files. We can take a bigger example. We'll go, something real world would be -D. We'll go to Windows System 32. -T. DLLs and EXEs, and we'll do that recursively as well, and we'll call it system32.db for a database file. And I got it wrong. -D. Oh, got to put another -T argument. Okay, there we go. In the program, while we're letting that crank, it's some like 4,000 files attaching. What I do for the hash function, right now it's doing just a SHA-1 hash, but I have it such that as long as the hash function is in hash lib, we can use it. So that could be an option coming up. Right now it's just hardwired to SHA-1, but anything in hash lib, we can use that for a hashing function. Okay, so we're back. We added 4,008 files to system32.db, and again, if we do the DIVT on that, it's going to crank away and check those files. Well, I'm using a SQLite database, so I had to kind of learn Python over again. It's been a while since I've done Python. I've never really done anything with SQL or SQLite, so please be kind in your comments, but I would appreciate any constructive comments on how I structured everything. Or I think my Python looks kind of C-like or Java-like. But it was a lot of learning the Python and a lot more of learning the SQL to get this whole thing working. And it could be cleaned up. I know it could be condensed a little bit, but it got it working, and it's kind of late right now, so I would like to go to bed. But okay, we have 4,008 files hashed and no problems found, and that's what we like to see. There's also a SQLite manager in Firefox, which is good for looking at the SQLite databases. And we'll go in and check out the system32.db we were just talking about. So there you see there's 4,008 files. Directories. I keep track of all the directories and whether we went in through them recursively. Hashes. I keep a table with all the hashes in there. And one of the future things I was looking at is, there you go. We have stuff where you'll have the same hash, two files, obviously same file, two different places. So that could be useful, especially if you're looking at your system and all of a sudden you start seeing duplicate hashes, especially with different file names. That can raise some red flags right there as far as being, you know, like malware. I've seen it where it comes in as different, you know, gets renamed various different file types, but it still has the same hash. And then this is stores the types that we're looking for. We added DLLs and EXEs. So kind of give you a rough overview of how it works. There's so many ways this could go in. Instead of being a text output, it could be, you know, comma separated values. I don't know what you would have value with or what has value to you. There could be something that take these hashes and anything where you have duplicate hashes or any. Just you could start pumping these hashes into VirusTotal. Yeah, I mean, I've like so many ideas for this. I think it's going to go into the next module as well. But I did build it to the point where it has all the functionality I need right now. I'm probably going to start actually using this Tuesday morning when I get back to work. So, but I look forward to any comments you may have for it. Like I said, any Python tips saying something really doesn't look Python-ish or, you know, SQLite. I know I could do it better, but it works for now. I plan to improve upon it. Looking forward to your input. Thank you much.